Hello student, the question says, consider circuit in figure, how much energy is absorbed by electrons from the initial state of no current to the state of drift velocity. So right now this is the given circuit and we need to find what is the energy absorbed by the electrons from the state of no current to the state of drift velocity. There is a follow-up question also. He is also asking electrons give up energy at the rate of Ra square per second to the thermal energy. What time scale would the number associate with energy in problem A? Okay, so let us try to discuss both the problems. So before that, let me take this circuit diagram to the next page. So this is the resistance given, and there is some useful information also given in the question, and we need this information while solving the problem. So I'll take this information also to this page. So this is the information that is given to us. Now, to find, let us assume we know the relation between current and drift velocity is I equals to NEA VD. So to find current, I equals to V by R. So this is the steady state current. V is 6 and R is 6. We know the current is 1 amperes. Let us use this information to find the drift velocity. Drift velocity is 1 divided by N is given as 10 power 29. You know, charge of electron is 1.6 into 10 power minus 19. And area is 1 mm square. So 10 power minus 3 whole square. So it would be 10 power minus 6. So if I go for this division, we got 1 divided by 1.6, which is 0.625 into 10 power minus, so we have 29 into 29 minus 25. So we get it as 4. So 10 power minus 4. So I'll write 6.25 into 10 power minus 5 meter per second. So once we got the drift speed, the energy gained by the electrons we can think all the energy gained by the electrons is simply like kinetic energy of the electrons. But there is a very important assumption we have to take here. We will assume that during the process of gaining this velocity, the electrons are not losing any of the energy. So during the process, they continuously collide, and we'll assume that they are not losing that much energy. And I think you know it, all the collisions we'll assume as perfectly elastic collision. So taking those into consideration, let us try to find what is the kinetic energy gained. So it is simply half mv square into total value. Total value is total number. So we can simply write it as half mv square. Total number would be number per unit volume into volume. So you will have, this is N is number of electrons per unit volume. If I multiply with volume, you will just get the total number. So half mv square into N. What is the volume of a cylinder? So we can write volume of the cylinder as area into length. Because if you take a wire is approximately like a cylinder, and the volume of a cylinder is, if this is area and this is length of the cylinder, we can write A into length as our volume. So let us try to substitute half into 9.1 into 10 power minus 31. It is the mass of the electron. And we got this value as 6.25 into 10 power minus 5, 6.25 into 10 power minus 5 into again 6.25 into 10 power minus 5. And the N value is given in the question as 10 power 29. And the area is given in the question as 10 power minus 6 meter square. And length value is given in the question as, let us see what's the value of length given as 10 centimeter. So 10 into 10 power minus 2. As you can see, this is like a very, very lengthy one. Let us try to multiply all of that patiently and see what's the value we get. So if we go for it, we'll have 9.1 into 6.25 into 6.25 into 10 divided by 2 would be 1777.34375 into 10 power. We have minus 31 minus 10 minus 6 minus 2 plus 29, which should be 10 power minus 20. So we can rearrange this as 1.78 into 1230, so 10 power minus 17 joule. So this is the value we obtained. This is the total kinetic energy we obtained after rearranging all the terms. So let us look at the second part of the solution. In the second part of this solution, he is asking you, electrons give up this energy at a rate of Ri square per second to the thermal energy. That means is indirectly saying the gained energy is lost as thermal energy at a fixed rate of Ri square. So let us try to find what is the power loss. The power loss would be R into R is this one, I value is 1 whole square. So we'll get 6 watt. Once we got 6 watt, we know power equal to energy by time. So here he is asking us to find the time it takes for this total power to lose. So let us assume this power is constant, then average power and instantaneous power, it doesn't matter. So we can just substitute everything and we can find the value. So time equals to 1.78 into 10 power minus 70 divided by 6. So 1.78 into 10 power minus 17 divided by 6. Let us do that. So 1.78 divided by 6, it would give us 0.2966. 0.2966 into 10 power minus 17, which is approximately 0.3 into 10 power minus 17, or you can write approximately 3 into 10 power minus 18 seconds. So as you can see, this is very little time. As soon as they gain energy, there will be losing energy. So as soon as you connect it, as soon as you close the switch, and as soon as the current starts to flow, you'll realize that heat is coming out of it. So this is how quickly things would operate in an electrical circuit. Hope you understood how I have solved. Thank you.